Mi nombre es Hanno Van Raalte, yo soy manager de Moldflow en Autodesk. Hablo algo de español, mi padre estaba profesor de español, pero casi no practico, por eso the rest of the presentation is going to be in English. So,
and the questions in Spanish?
Sure, okay, no problem. I did a presentation a couple of days ago, and it was a 2-hour presentation. I figured I have to condense it a little bit. So what I covered today is an update for like the 2026 release, as well as the updates, so we get the most important highlights of the release. Go over a couple of technology preview features that we have available. The technology preview, like Lorena said, is a free beta you can participate in. We make new functionality available, and we're looking for feedback. So some of the things that we believe that are like ready for like getting some input from customers with, we make them available. If you use them, and let us know if they're working for you or not. And like any kind of information is good information at this point. And then we have a couple of things in research and development that I'll cover. So I'll go through the product release really quick, because like you have this available, and I've presented it on this a couple of times in different locations. So this is an overview of the release. I'm not going to cover this in great detail, but I'll in the next couple of slides go through some of the most important things of the major release. The first thing is we added a new way to visualize workbench results. So in a similar way that we get if you get data from a scanner, like a laser scanner, it's presented in a different way than we typically present in Moldflow. So in Moldflow, we typically always look at absolute deformation, so without the direction, whereas in laser scan data, you have a directional component to it. So depending on if you look at the part from the top or the bottom, on a laser scan data, you get a different view of the data. And we're trying to create an additional plot to make this more similar to what they do in the laser scanning world. So in this particular case, you'll see there's a simple plot. The way we traditionally display this result is like you will see the high and the low points, but like the high points are always, or where we have the most information is always going to be in red. Whereas in the scanner data, you'll find areas that are going up in a positive normal direction are going to be red, and things that are moving in a negative normal direction are in blue. So there's a different way of displaying the data. It's the same data, just a way of displaying, making it more convenient for you to compare Moldflow data with scan data. So again, the different way to look at it is like in Moldflow, when we look at workbench, we always the areas that have most information will always get the same, always display in red. We're now in the new plots data, if the depending on what you look at, in which direction you look at the data, you will get to see something displaying in blue or primarily in red, where the data who has no deformation will be in green. So it's an additional plot next to the existing plots that you have. Just another way to easier compare Moldflow workbench results to scanner data. Another thing we did is we spent quite a bit of time trying to speed up Moldflow flow results, 3D flow results. We did this year using basically reformatting our result data. Whereas in the past, like if you run an analysis, you get intermediate results back, and while the intermediate results file is written, the solver stops temporarily and the data gets transferred. And the problem here is that like if until now we had always had a growing file for the intermediate results, so the file gets larger and larger and larger. And if this gets transferred on your local machine or over a network, the amount of data transfer that's happening it's going to be get larger and larger the more the solve progresses. And as a consequence, your solver pauses for longer and longer and longer. In the new release, we changed the way we display write the intermediate results just by looking at the delta between the current time step and a previous time step, which means that we'll only have small files with transferring, which means the amount of time the analysis pauses is going to be shorter, which means that you're going to get a good amount of speed up. I had a couple of slides that I'm hiding right now, but basically on a particular case where I'm using default settings, using 2025 on a medium-sized model, solving on my local machine, we're able to get 30% speed improvement. But if you submit over a network, there's also data transfer over the network taking place, adding additional load up to the situation. So the bottom line is the more intermediate results you have, and the larger the model you have, the more speed you're going to get in a new release. So this is a much more efficient way of solving. The only downside this is going to get you though is that this new file format is not understood by previous releases of Moldflow, Synergy, and Communicator, which means that if you generate a new data set with 2026 and somebody you work with only has Moldflow Synergy 2025 or 2024 installed, that Synergy does not understand the new file format, right? So the people you work with, please get them also the same release that you're on. The other way around, if you have data set that's created in 2024 and 2025 or before and read it into 2026, no problem. Just data that you generate now is not backward compatible with the previous versions of Synergy. So the same thing goes for Communicator, right? So just really important to be aware of. Another thing we spent quite a bit of time on is speeding up some modeling operations in Moldflow. So if you work with large models, certain things like merging nodes can become really time consuming and really not great. So we spent quite a bit of time on improving that in this release. So I created a quick video on and just this slide basically to make you familiar with what I'm doing here. Is I created a medium-sized model, and I created a situation where my runner system is disconnected from the TED mesh. So in the next slide, I'm going to merge those two nodes in my analysis. So I'll do the merge operation in the left and the right screen. So the left screen is basically Moldflow 2025 and 2026 on the right hand side. And I basically do the same operations at exactly the same time, start the operation at exactly the same time. I just we'll see two mouse movements happening at the same time, and I try to time them as much as possible to the same time step. So I'll basically set up the merge operation here, hit apply at the same time, and 2026 is done in 2 seconds, and 2025 takes a lot longer. Okay, it's done in 11 seconds. So it's more than 5 times faster. There's other operations like moving data from to a layer that is also like sped up significantly. So the other thing we're doing is at the moment modernizing Synergy. So we are now exporting animations in MP4 format, which is a much more common modern animation formats. So I'm not going to spend too much time on it. We can now export also larger communicator files, larger than 2 gigabytes. In the past, we were limited to 2 gigabyte files. We now have the ability to export significantly larger models for the communicator and your zip archives. Also moving our command line now to PowerShell. This is an upgrade from the old command shell that's whole command line window from Windows moving away from that and now moving to PowerShell. We're following that direction from Windows, Microsoft, and it's largely the same, just a little semantic differences in how you some commands. There's a large amount of help available online about the new sort of the PowerShell commands. I put a link in here that will be available in the.
I have a question about that.
Go.
Is it the same way to go into the new PowerShell command
Yes.
that the way to
Yes,
the
it's exactly the same. It looks the same. The only thing is the commands are like maybe slightly different. In this particular case, in the old command window, you basically just had to reference the VBS and it will execute it.
Yeah.
In the new world, you basically have to say add the n% sign in front of it, which means execute,
Okay.
and then the path to the VBS.
Okay.
It's very similar, little nuance differences. If you're familiar with Linux, this is nearly identical to Linux environments. The most important thing I want to spend a bit of time on is the availability for stamp as the default shrinkage model. So, as long-term users, you are familiar with trims as a way to improve shrinkage, warpage and shrinkage predictions using shrinkage data that we have collected over the last decades. But now we have the ability to actually do the same thing now for the 3D warp domain. So a couple of important things here is that that you do not actually require any additional tests. So if the material that you're using already has shrinkage data included, then you can use stamp in the if you pick the same material in the 2026 release. Everybody automatically will have the crims now, stamp as a default model. We actually applied for a patent in the last year, and we got that approved in February of this year. So quickly, just to give you an idea of why this matters. So a couple of slides over here for this is for the residual stress model, so the old default model, and this is for stamp. On the bottom, you find the measured data, and the predictions are with the residual stress or stamp model are in a vertical line. Now, if the predictions are matching identically to the measurements, then the data point will fall under the on the diagonal line. So the important thing is, like, when we were looking always for data that is very closely centered around the diagonal line. If that's the case, then we can do a really good job with the prediction of work, workage. So in this particular case, like I said, for unfilled polymers, flow direction, you see pretty good correlation. Transfer flow, you will see that, like, uncorrected residual stress, like, we do see a fair bit of scatter away from the diagonal line, which means that we have an error. But with stamp, we see like a very nicely centered around the diagonal line, which means, again, you do a really good job with the predictions. Same thing for fiberflow materials. Again, we see fair bit of scatter around between measured data and the shrinkage prediction. With residual stress and with stamp, we see a very nicely centered data structure around the diagonal line. For flow direction, and the same thing for the transfer flow direction. Again, so this is pretty impactful. We worked on this for I want to say full-time 3-4 years. So almost the entire Sobre team was working on this, and we, I think, did a pretty good job getting this out. We've gotten really good feedback on since we released this. So moving on to the tech preview, sorry, not the tech preview, the update one. Again, overview slide. I'm not going to go into the details here again. I'll cover the most important ones in the next slides. Similar to what I showed earlier, the video, we're speeding up analysis, the merge nodes thing. We also made some improvement at delete node commands. So again, on the right hand side we have 2025. That's inside we have the update 1 release for 2026, and you will see a node floating in midair. I'm going to delete that node, and our time is exactly the same. So in the new release, this is very fast. In the old release, you have to be patient. So 12 seconds. So significant speed improvements. Again, if you do delete a node once in a day, it doesn't matter that much. But if you do this on a frequent basis, these things become pretty annoying. And I hope that you're going to find this very good improvement. The other thing we did is we moved now away from Visual Basic scripting. So similar to what I mentioned earlier about the PowerShell, Microsoft is also moving away from VBS. So a couple of important, and we're moving our scripting language to Python. So if you install the 2026 update 1 release and record a macro, it will now be a Python-based script that we are creating. Important to note is that if you have scripts created on using VBS, they will continue to work. There's not a problem. Just new work, I would say, try to move it to Python as a way forward. It's a very commonly used scripting language. So if you hire new people from universities, or Python is a very commonly understood language, so much more so than VBS. So a couple of the important things here. I said the existing scripts can work. The other side effect is that now, if you make an error in the Python script, the error message you're getting back actually will also possibly have a suggestion what the problem is. So over here on the bottom, you see that I made a typo in the scripts, and it actually figures out, hey, maybe the problem actually is that you have a typo in the word. You may have meant the word delete here. So it'll try to make you make use of the Python capabilities and suggesting the possible cure for your problem. So there's a couple of things that I'm going to cover with respect to Scandium, and I mentioned already Scandium Technology Preview is a sort of a preview beta version for Moldflow. We cannot guarantee that the things we're working on are going to be commercially available. If they don't pass our testing requirements or we don't get good feedback, we're not going to release it. So therefore, there's not a guarantee that this is going to make it into a commercial release. Just the thing is, like, it's something we're working on. Important here is that please, if you use the Scandium Technology Preview, let us know if the things that we're testing and working on work for you. So feedback is super important. This is why we actually release this, to get some data in the field. We cannot cover everything in testing, and just some feedback on how things work, or like maybe we missed something in the implementation. Feedback is important here. So the first thing is that is new in the technology preview is that we are revisiting our valve gates timing. So in the current commercial release, if you set up a valve gate and you open it by time, you can only close it by time. If you open it by RAM position, you can only close it by RAM position. In reality, you can open by time and close by RAM position, or the other way around. There's a lot of flexibility that you can set up valve gates. We now have covered the existing behavior that you've had for a long time in the legacy valve gate controller, but add a new mixed valve gate controller where we mix the open and closing of valve gates. The way this works is that you basically select your valve gates, the hot gate where you want to apply the valve gate, go to properties, Added that to one element only. Now specified you want to create a mixed valve create trigger. Get this dialog, and then move to a new dialog that you have not seen before. But in this dialog, you can specify you open the valve gate by time or by any other different means, and closing by, again, any other different means. As well as you can specify a velocity control valve gate as well. In this case, I show you over here like what you can open with. The same, this is available for closing as well. Another couple of things that are interesting maybe is the new options for closing at end of fill and closing at end of packing. And it's particularly important because in the last, since 2025, we also have the automatic packing profile where we can close the packing at an appropriate time for that particular model or for that particular part. If you don't know exactly when the valve gate closes, it's really hard for you to specify a time when to close it. So we now have also the end of packing as an option in the valve gate. That's all I'm gonna say about this. Again, one important thing is that we have not actually done the user interface setup correctly. This is really working on the solver side. The way you set it up right now is it works, but it's not has not all the bells and whistles that you're used to. So, for instance, like if you are used to editing the valve gate controllers in a table form, that does not work for the new implementation yet. So, there's more work to be done on our side. We know this. We just want to make sure that this gets used by customers and get feedback. Does it work? Are we missing things? There's a lot of combinations to test here, so feedback here is super important. Another thing is that we have made some modifications to the way we deal with inserts in the warpage context. Basically, what we're doing now is extending the residual stress model to inserts. So this gets so if the insert heats up and cools down, that stress gets built up, gets captured now in a new warp situation with inserts overmolding. This is a first step. So this is really for insert overmolding at the moment, not for two-shot overmolding. The next step for us is to include the same mechanisms in two-shot overmolding. So moving on over to research projects. Again, no promises, this is all work in progress. An important thing that we're working on is basically making some modifications to measure, in the fact that we want to make sure that when we measure part, that the area under the gates gets sufficient number of elements and a uniform distribution of nodes that we can map data from the runner system to the TED mesh tool. So as a bit of background, so like when we have the situation, we connect a runner system, beam runner system to a TED mesh. Every layer in the runner system will try to map the data locally to the TED mesh locally. So we're always trying to get multiple nodes underneath the gate to map to. The issue is a little bit that if the distribution of the nodes is not symmetrical, it means that we can create a very asymmetrical situation in the sense that, like, if certain areas have nodes to map to and other part of the runner system have nothing to map to, then we have locally a very asymmetrical situation. So and that can become a problem if you have, let's say, a multi-cavity runner system or like a multi-cavity system where the parts are completely symmetrical, and in one gate we have a much better mapping situation on the other side, and now we have a weld line in position that we don't want it to be, right? So the new behavior is basically to ensure we have proper mapping underneath the gates, in a symmetrical way, sufficient coverage, and yeah, that's we see in testing that it actually is making a big impact in the predictive accuracy. Another thing we are working on is working on reducing the difference between dual domain work predictions and 3D. Two areas in particular that we're working on is basically addressing one of the fundamental differences in the way dual domain work is handling low RIP situations. In dual domain, we see that they're actually being presented as too stiff. So we're trying to actually address that with a modification to the way we treat low like models in dual domain with low RIPs, make it more similar to how this actually be predicted in 3D. Another important thing is that we are looking at improving the thickness shrinkage in 3D, which will effectively introduce something akin to a corner effect in models. In dual domain, there's an option to turn on corner effects in certain ways. In the new thickness shrinkage improvement, this actually should come in organically in the 3D flow solver when turned on. So we've had it for a while. In the technology preview, but like we have not released it because we didn't know exactly how the new thickness shrinkage would work in the same way with in combination with stamp, because both were doing things with shrinkage, and is the overlap, is this actually working if we combine both thickness shrinkage effect in combination with stamp, and it turns out looks like it actually is working correctly. Another important thing is that over the year, and specifically when we released Stamp in Technology preview form, we got an unexpected feedback on a particular model, and when we looked at it closely, the cause of the discrepancy between what we were expecting in the analysis versus what we were getting was actually the fact that the material had talc in it, and we did not actually expect talc to have an orientation. If you look at the multiple material database and look at the talc filler, you will see that the aspect ratio of talc is 1, which means there's no orientation effects, which means we are not going to calculate orientation effects, and therefore work will not actually show any orientation effects in the warpage analysis. That assumption of talc being a sphere or like a cube is actually not correct from our understanding. So if you turn on, basically go to the database and make your fiber a flake or set the aspect ratio to 0.01, for instance, that will trigger the orientation calculation in Moldflow, similar to the fiber orientation. And that will actually make sure that the analysis we're doing next will account for orientation effects due to the talc filler. In that, the case that we actually were exploring at the time of the stamp improvement, in a sense, when we turned on the flake orientation, all of a sudden the analysis was giving the right trend and everything looks to be matching correctly. So that got us on the path. We started to work with the university. We basically molded a sample with talc in it, sent it to the university, and looked at, okay, what does it look like? The talc look like? And it clearly turned out like the talc that we were using was very much spherical, a platelet or a flake, effectively. So we're at the moment working on a project together with a material supplier in the US to do more experimentation and make sure that we're doing the right thing here. I also went to the K show a month ago, and actually was talking to a couple of producers of talc and asked them straightforward question: is that a flake or is it a spherical? And they said it's definitely 99.9% a flake. You can create them as sphericals if you use artificially created talc. That will be a spherical. But if natural talc, which is the cheaper version, like 3 times cheaper than the artificial or synthetic talc, that will be 100% flake, guaranteed. So, and considering price matters, we should expect 99.9% of the cases that we're running into going to be talc flake. We did initially think about just turning the data into the model into flakes in our database for all types of materials. However, we did see some unexpected behavior in the dual domain and mid-plane world. So before we make the change, we have to make sure that we actually capturing the right behavior on the mid-plane dual domain predictions as well. So we know for a fact this works really well for 3D, but like we need to do a bit more work to convince ourselves.
But if I do it right now with the database, if I change it to a flake in 3D, it would work?
Yes. Yes. So I would say be careful with mid-plane dual domain at the moment.
Okay, but 3D.
3D works, and it also works with combination with stamp.
Okay.
So.
Good enough.
Yeah. No. So, but the thing is, like we're pretty convinced that this is the right direction, and we're gonna solve this. But like I said, before we make a sweeping change, we have to make sure that we're not breaking mid-plane dual domain here.
Yeah. Okay.
We have some research going on in the area of recycled content, recycled materials. So I'll breeze through this real quick. On the left-hand side, we have a table over here where we have certain properties for a prime material or like a virgin material. And if you were to look at post-industrial recycled materials for those particular grades, they don't vary that much from the virgin material. So the material streams are pretty well contained, and the variation in that post-industrial waste is not that great. If you mix in recycled content here, like you're gonna be doing the variations that you're gonna see are gonna be very small compared to virgin materials. However, for consumer products, post-consumer waste, this is a lot more complicated because now we're dealing with like how do you separate a plastic bag from a housing of some sort, and how do you keep those streams clean in that sense, and that becomes you see a lot more variation in the properties we're getting from post-consumer recycled materials. And now if you mix in, let's say, a certain percentage of post-consumer recycled materials, what are the implications for the use of it in your applications, right? So if you use a material with a recycled content in them, do you expect a lot of variation in your work and your pressure predictions, or is it going to be maintained? A lot of questions still out there. We have questions, we have opinions about this, material suppliers have opinions about it. We're working with some material suppliers to sort of move this forward. We have some ideas about building up a DOAE where we say like, hey, rather than give you a number of injection pressure or a specific work shape, maybe we can look to like, hey, we believe that within a 90% interval, the maximum injection pressure will be between this number and that number, and the warp shape will be between this and that. Still something we're thinking about. It's still very much in development and exploratory work. A lot of discussion still happening with the material suppliers on this end. We're living now in the world of AI, and so we're also looking at can we build out rather than predicting a let's say predicting cooling analysis using our normal algorithms, if we train a model on thousands and thousands of different combinations of part geometries, mold geometries, and cooling layout, can we start coming up with an AI that can predict or estimate what a cooling mold cooling distribution would look like? That would be a lot quicker, right? So where we're in a Moldflow world, it can take maybe an hour or two for a cooling analysis to complete on a large model. With a pre-trained model, maybe this can be sped up by taking 2 seconds to complete. And it may not be 100% accurate, but the value of, so the cooling distribution doesn't always have to be pinpoint accurate, like as long as it's within, let's say, 10% error, that would still be extremely useful. But it also opens up the opportunity to make things more interactive. So if you were to say, we're going to build a cooling channel, we do an estimation of the cooling channel, and now if I move the cooling channel up, we may be able to give you in real time an insight into what the new position would actually give you in terms of improvements. So again, still very much a work in progress. To give you a bit of insight into where we're currently are at. So in this particular case, the left 2 images are basically our normal analysis predictions on a particular test model, and with the trained model that we have, we are able to capture the temperature in a pretty reasonably accurate way, as well as the heat flux. This is a good result. We also have some worse results, so there's still a lot of work to be done here. Same thing for a cool BEM mold temperature distribution on the same spot. We can predict what that looks like with a new neural network. Like I said, there's still a lot of work to be done here in this particular area. We're also working on a new cool solver that is using technology that was invented by a team in Poland, one of our teams in Poland, that basically built their reputation around generative design, so more like a structural application. We're now building it out to take their structural solver and actually applying it to thermal analysis. So one of the cool things is that they're using a voxelization technology. So rather than creating a TED mesh for a mold, we have a really quick way to generate a voxel mesh and a multi-resolution voxel mesh. So a traditional voxel mesh, you have a uniform voxel size, and if you can sort of imagine this being a part, this area being occupied by cooling channels, and the detail of how things connect between the part and the mold, or the cooling channel and the mold, will dictate normally the size of your voxels, and they will be the smallest resolution that you need will be applied everywhere. In this particular case, we actually are applying a multi-resolution voxel model. So we are getting a lot of detail where we need it, but we grow it out to areas where we don't need a lot of detail. So on the outside, for instance, we will actually have much coarser voxel meshes, and the solver can handle this wide distribution of voxelization. So this is a bit further progressed than the other technology we showed you earlier. So this particular case, again, we have the mold cavity interface. This is comparing the mold temperature distribution on a TED mesh, and this is with a new cool frame solver we are creating. So there's a lot of very good correlation here. I expect this to be going out first in a technology preview, so additional functionality we're offering in a commercial product for feedback. This is going to be an area that is going to have to grow. The initial release mode will most likely be contained to what you, so simple models, simple geometries, and no inserts, no sliders or whatever, just a basic Moldflow analysis in a sense. So cooling channels, but beams, runner systems, tetras and beams, part is tetras, or dual domain, I believe. And the mold boundary will basically be meshed in with voxels. So again, this is an area that should make the analysis a lot faster as well as the meshing more robust, and give good results. Another thing we're working on right now is, so in the 2025 release we had the cooling channel optimization, but it was really aimed at conformal cooling or like 3D printed mold cores. In the new release, you guys haven't seen this yet. No. We are aiming for a drill and plug analysis. So basically, rather than having the optimization being done with 3D printed cores in mind, we're now repositioning the position of the mold cooling channels just by transformation, bringing close to as close to the mold as we can. And there are areas where the deep pockets, we automatically grow bubbles or baffles, and we grow them into part as deep as we can make them. Just to make this the mold cooling more efficient. So again, work is progressing here. I think I just sent it out for internal testing to a couple of application engineers within Autodesk. I have hope that it's going to be commercialized not too long. And lastly, in terms of AI, so the other thing we're working on is basically creating a connection between a Moldflow chat window. In Autodesk, we already have an Autodesk assistant, but this is being redeveloped as within Autodesk as a platform component. And we now have a way to talk to the type commands in this Autodesk assistant actually, and it will execute what it does in Infinity. So in this little demo, what I'll show that it can actually, I can ask it to change the results, ask it to also composite questions. So I was like, my question is going to be, please show me fill-time result and actually turn the histogram plot on, so a composite question, and it actually will do the job. And I'll ask it to generate a summary for me. It will go through the analysis that we just did and pull out a lot of the sort of hallmarks of the analysis, like what's the maximum injection pressure, what's the maximum planned force, how much work is there, and basically ask like the question like, where are the areas that I should be concerned about? So it highlights the areas that are problematic in our opinion. If your injection pressure is too close to what the machine can handle, that's a problem you should address, right? So highlight the areas of concern, and then you can ask the question, what do you recommend me to do next? And if, let's say, 5 of the different problems we're flagging all point to the same solution, as in inject slower, then that would be a resolution that we would recommend, or pick a different injection molding machine. So I'll play the video real quick. This was a video was played at Autodesk University. So again, I type a command over here. Ask the composite question, change the show me the analysis result in and I turn the histogram plot on. It does that. It's good. And then I ask a quick summary for me in a table form. You have some pre-canned questions, so you can actually click a button. You don't always have to type it in. You can just click a button for like predefined questions, and we'll create a table with some areas that are concerns, and then like the next question is like, what should I do next? And it will make a recommendation based on the multiple knowledge base. So this is still a very early concept. So we believe there's a lot of potential here to do really impactful things. But this has to grow. We have to basically feed it more commands that it knows what to do with, as well as the knowledge base we have to grow. So, and we have to work with a platform team in Autodesk that has input from a million other products with requirements. So the initial rollout for this is going to be very basic. The intent for us is to grow the capabilities in this particular area, capabilities that, and we're looking for feedback again. So this is like very basic at first. If you see particular applications that you would like to see in the product, let me know. So, and I think that's the last thing I have in my presentation.